So I apologize that this is maybe a little harder to read and coming at you all at once. So when these are some concepts here about fisheries management. The term maximum sustainable yield is the maximum amount of a particular species that can be fished in a sustainable manner. In other words, so that you can have equivalent productive yields in the future. If a population is overfished, then that means that there is not enough breeding stock available for sustainable replenishment. And when a species becomes overfished, it may become what we say is commercially extinct, meaning that it is no longer profitable to go out and fish for these species. It may still be very much alive and present, but in a population that is, is not possible to fish profitably. And then another term here are by-kills. These are animals unintentionally killed when other species are being harvested. That last term, here are some examples from your textbook. So this is an example of what looks like a sea lion caught in a net here. This was not intended to be fished, and yet there it was. You often hear of dolphins being trapped in tuna nets, and then dolphins becoming by-kill in that respect. A topic that has been of interest in previous decades is the fishing of whales. And whales, through really the 1800s, especially, and then into the 1900s, were heavily fished for many products that did not exist in any alternative way. Nowadays, there are many other products that can be produced without fishing for whales. I think I mentioned earlier one example of material that was harvested from whales was the baleen, which has kind of the consistency of plastic for combs, for anything that required something to bend or be flexible. Well, nowadays, of course, there's plastic that can be made from petroleum. This shows the rates of fishing for a number of varieties of species through the decades, and gives you an example of the pattern of fishing that leads to commercial extinction. So here we've got the blue whales, humpbacks, sperm whales, and so by about 1980, in part through commercial pressures, but also international treaty, fishing of whales dropped off significantly. So that now it's relatively minimal. If we can come off this just for a second there. So we've been looking at just making some comments here about physical resources, biological resources, marine energy resources, something that wasn't really focused on in any heavy way in the program you saw. Some examples of this can include wind energy from the oceans, and this has been done off coast in Western Europe in a few places here with windmills set up, because What's ideal about setting up windmills in the ocean is you don't have topography or topographic features interfering with the flow of the wind. So it blows more strongly over the oceans and can be tapped for energy. And there is very typically a lot of wind movement over the oceans than you often see on land. This can also include tidal energy. Here we learned how tides flow back and forth, and as the water flows, then turbines can be placed underwater to take advantage of that flow from one direction or another. Looking for one image that I'm not finding immediately here. I think it's in the slides. So let's come off the slides here just for a second while I flip through that. So another source of energy from the oceans takes advantage of the heat differential from the surface and then from depth in the ocean, particularly near shore. And this is an interesting concept here. Energy can be tapped from the heat that exists, and in this case, ammonia is used as a way to transfer heat from the oceans and into a more usable form. In some ways, this is maybe a similar type of idea where cool water from depth near shore can be used to cool off, or can be pumped on shore and cooled off, used to cool buildings in certain ways, or to cool off what is needed. And then finally, just a brief comment here about the non-extractive resources.